if this first problem had said 2/5, no it isn't, plus 3/5? Come on in. What if it had said that? Now what is that? Oh, I know what it is. I'm just not able to. This is off. I gotta. Okay, well, we'll just record myself playing this game. Okay. Okay, let's see if that works now. Let me try this again. Unfortunately, my videos are real time, so when something like that happens, you have to, well, you can probably fast forward through it. What if you had 2/5 plus 3/5? What would you do? Do you remember what you do?
She wants to make it her
Oh,
smaller. Do you want to make this part smaller?
Yeah, the writing part.
yeah.
Writing.
Make the screen bigger. So we can just erase all that. And so then, when you do this,
No, go back.
oh, yeah. So when you go back, you do like this. But if you make it big, like that now, then when you make it, it'll be smaller.
Mm-hmm.
So what I do is make that big. Otherwise, it's hard to write on there. Okay, Gabe, what if I had 2/5 plus 3/5? Do you remember what you do with that? Elias? You add the 2 and the 3 together, and you get 5 out of 5, which of course I would like to reduce that. Because what is that, Michael? Yeah, it's 1. Okay, we're going to start working with variables pretty soon. X here, and everybody needs to pay attention. Okay, I need all eyes up here. X's stand for any number. Okay, Josh? It could represent any number. It can't be 0 in this case. What's the problem with 0? Well, 0 times something is 0. But what if I had 0? Then it would be 2 over 0 plus 3 over 0. Can we divide by 0? No. But X stands for any number. But you know, these are both the same number. So you know what I have to do to add these? I just leave the X alone and just add the 2 and 3. It doesn't matter if X is 5, X is 6, X is 7. It doesn't matter. So what am I going to get in the numerator, Josh? Yeah. That's it. You don't add the X's. We never added the denominators. What I need you to start understanding, this is a letter that represents any number. So algebra is just arithmetic with letters in it. And all the rules for arithmetic that you supposedly know apply. Well, what about this one? These denominators aren't the same. I'd like to make them the same. So I'm going to write this way, but normally in algebra, we write them horizontally the way it's written. Okay? Now, when in doubt, you can multiply them together. I don't want to get exponents involved here. But what if I have this as 2x? This is 1 over 2x. And what if I wanted to make this 2x? How would I get from x to 2x? How would you do that? Not add, not subtract, not divide, 1 left. Multiply. Okay, husband? Multiply by 2. If I put a 2 there, now they look the same, don't they? And then I put a 2 here. Now I can go ahead and add these. This is a little extension here. So what's 2 plus 1, Michael? 3 over. And do we do anything with the denominator? No, we leave it alone. Okay, so that's a little harder, but it's still the fact that it doesn't matter if this had been 1/5 and this had been 10. I could have done something like that. I'm not worried about this or that other problem right now. We're going to do order of operations, and there's some things here I probably will skip. So we're going to go on to the next slide, and what we're going to do is look at the effect of changing the order of operations when evaluating expressions, and you're going to be evaluating numerical expressions. I have to get him in because he's not in.
Is he enrolled?
No, I have to do it back there. Okay, students will use the order of operations to evaluate numerical expressions, a lot of big words. Okay, so where do you start? Okay, I'll let you answer those. I'm going to help. Oh man, I don't know how to spell his name. Our new student. Yes, but I'm going to need. Oh no, that's not what I want. Yeah. Okay. Whoa, 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 I'm in the wrong place. Just probably the last name is probably all I need. Obsessed. What did that do? There it is. Mubarak, right? Sometimes it does that. Okay. Now, this is an expression. So we have equation, we have expressions, we switch pages, Michael. Yep. We have evaluate, all these E words. We have exponents. So you have, just like in Spanish class, you have vocabulary you have to learn. An expression, I would say an expression is like a math phrase. Math phrase. Okay? It is not an equation. You know what a phrase is? It's just part of a sentence, right? The brown dog. Actually, I had a green dog because I colored my mini with green, but that's an expression. There's no action, there's no verb. Okay, so the question is, this is an expression because there's no equal signs, and how many numbers are there? CJ, how many numbers? 3. Does this move? Oh, look at that. Magic. And the numbers are, you could write it down, 3, 4, and 2. Oh, that's kind of cool. That's worth it just to see that. I don't know how you do that. Okay, how many operations? You know what operations are? Well, we've got a lot of operations, but right now, you know of add, subtract, multiply, and divide. And by the way, order of operations is always a problem for students, no matter what math level they're at. So this is something that's really important. We have agreed that we will perform operations in the same order. And somebody could have decided a different order. I don't care. So what operations are here? How many? 2. I've got, I feel like Vanna White. What are the operations? What's the first one? Adding and multiplication. Okay? So we're going to have to figure out how to simplify that expression. Some people would like to add the 3 and the 4 first, and then multiply by 2. Some people want to multiply the 4 and the 2 first, and then add 3. So we're going to come to an agreement about the order in which we do these. So Jack got 14 for the answer, and Jill got 11. And we are going to evaluate, which means exactly what it sounds like, find the value. You see the word, do you see value in here? There it is. Not spelled correctly, but evaluate. I want to find the value of that. How did Jack get 14? Anybody know what he did? What did he do? So he did 3 plus 4, which is 7, and then he did 7 times 2. Notice I did not linked all that together because that would be wrong. Well, that's wrong anyway, but. So you got to be careful how you write things out, because I've seen it written out incorrectly on the AP exam, and we mark it wrong, even though it's not calculus. Any kind of math they write incorrectly, we mark wrong. Okay, so we got 14. How about Jill? What did she do? Paris? Yep, so she got 11. Okay, we are going to agree to follow certain rules. And there's his explanation. So that's how we got 14. We already got that in there. We got that done too. And so we have a certain order of operations. So you're going to have to slide your file forward. Okay. There's a whole bunch of stuff there. I don't know. You gotta keep. I don't have page numbers. 9. Oh. No, I don't like this page anyway. That's because this is supposed to. You're supposed to do something with this one. Okay. We're not gonna even do a hypothesis. Do you remember order of operations? What's the first thing you do? Parentheses. I think that's what this is going to say. Oh, look at that. Evaluate inside the parentheses. Do you remember the second thing? Remember, it's please excuse my dear Aunt Sally. Do you remember that? CJ, have you heard that one before? PEMDAS? So the next thing we do would be exponents, but I don't know if they're in this. Oh, there they are. Evaluate powers, I'd call those exponents. Oh, yeah, because there's a lot of stuff here that we don't need. Okay, and you can't pull those because it's just a picture. Yeah, so you're going to have to write it. So I would say parentheses. Exponents. Third is multiplication and division. And you know what? This is a little incomplete because you have to go from the left side to the right side. You have to clear it all out. So I don't care which occurs first, multiplication or division. It doesn't matter. I just have to go left to right. So it says multiply or divide. I'm going to rewrite it so I slow down. Multiply or divide left to right. You can't switch the order on division. 2 divided by 4, 4 divided by 2 are not the same things. That's why we have to worry about going left to right. Otherwise, I'd just say do all the multiplication division. And then the last one is what's left. Add and subtract. And it doesn't matter which one comes first. You have to go in the order of left to right. It's the same problem. So you add or subtract. Left to right. And you guys know this as, please excuse my dear Aunt Sally, where this is the parentheses. Oh, we just do that. Those are the exponents. Be careful with the multiplication division. A lot of you think you have to get all the multiplication done first. This is an or. Multiplication, division, and same thing with adding, subtracting. And that's okay. It bamboozles everybody. You are not the only ones.
If I could just interject something, I was a cover teacher in the higher algebra class last year, and we use this all the time. We always came back to it, so just keep that in mind. We'll go with you to each math we go to.
And it's just because somebody, the math people, agreed to do it in this order. They could have agreed on a different order. But we're all going to do the same thing so that we all get the same answer. Jack and Jill got different answers. So it didn't matter which way you want to do it, but we've agreed to do it this way. So we're kind of stuck with what somebody else decided. Because there is no right or wrong way. If I wanted to do the 3 and 4 first, I'd have to have parentheses. Okay, so do we get to some problems yet? Okay, there we go. Oh, does this have a big F on it too? Oh, there we go. Let's just do the problems rather than making this so complicated. Use the order you created to complete the table. So, am I going to subtract 10 and 3 first, or am I going to multiply? You're going to multiply, right? So it's going to be 10 minus, multiply those, 6. And what's 10 minus 6? Josh, what's 10 take away 6? 4. Shall we see what this says here? Oh, look at that.
What's the third operator?
There isn't one. They're getting ready for the third problem. It's kind of a nice little slide, actually. Okay, so what are we going to do first? Are we going to multiply 4 times 3, or are we going to go 3 times 3? Do you remember what exponents mean? So if I have 4 to the third, that means it's a shorthand for 4 times 4 times 4. That's what an exponent means. Remember that? What if I have 4 times 3? You know what that means? 4 plus 4 plus 4. So multiplication is shorthand for repeated adding. Exponents are shorthand for repeated multiplying. Well, you probably never thought of that before, but that's what it is. We need to know that. So what are we going to do first here? Are we going to multiply or do that exponent? Please excuse. So what goes next? Exponents. So it's 4 times, and what's 3 squared? You okay with that? 3 times 3, which is 9. And 4 times 9 is 36. The 3 is for the last one. Let's see. Yes.
My writing is off.
Well, that one I can't help, I don't think. Can you make it bigger? Does that now work? Okay, so 4 times 9. Is that better?
Yeah.
I like to make them big.
Actually, the writing off. All you have to do is tap the writing and then you can move it.
Tap the what?
Tap the see. So it's like this, and then you just tap it and you can move it
Oh. How'd you get such nice writing? Were you typing?
up here.
Ah. Some people are using the typing part rather than doing handwriting, which is nice. Okay, what's the first thing we have to do here? Are we ready? The parentheses. So we're going to do this little guy right here. What's 8 take away 5? 3 times 2 cubed. Now, do I get to multiply 3 times 2 first, or do I have to cube the 2? Cube the 2. So does anybody know what 2 times 2 times 2 is? Okay, it's not 6. That would be 3 times 2. This is 2 times itself 3 times. Don't feel bad if you get that wrong, because it happens in all the different levels of mathematics. I'm sure Mrs. Liedall has seen that too.
Yeah. Oh, absolutely.
Okay, 2 cubed. 2 times 2 is 4. Times 2 again is 8. Okay, so that's 8. What's 2 times 8? 16. Now, if you use my calculators and you type it in as written, you will always do the order of operations correctly. The calculator's programmed to do the same as what we're doing. Yes, you have to type in it exactly as written. Whoa, what did I do wrong? Oh, did I forget something? Oh, I copied it wrong. Well, that'll do it. That should have been a 3. I was thinking of all those 2's. You know what happens? And, you know, if you think about it, when I make mistakes, I do a lot of this stuff and I make mistakes. So if you haven't practiced much, you're going to make more mistakes than me. Probably. I think more mistakes than I make. Okay, PEMDAS. We already done that. So who is right here? Jill is right. Jack isn't really that far off. He's just not following our agreement on order of operations. That's all. Okay, there's a bunch of problems to try. Oh, these are supposed to be centios, but I'm not going to do centios, although I have them. Yours is that way too? And I think that's the end of that. Okay, I have a worksheet then. Let's do the worksheet. Where did I put it? So you're going to write down the order of operations on your worksheet, and we'll do a couple of these together.
So if you add it to your assignment record,
So this is
what you're gonna do and have ready tomorrow.
right. Try to do it without a calculator. If you need a calculator for arithmetic, then use your calculator for that. So you should not be really needing your iPads unless you want to look at your notes. You can have it for notes, yeah. Well, you could have done some of those problems, but that's okay. Yeah, that's unfortunate that that's there. Okay, you should have that problem done since we did that. And the first step here is to write down the order of operations. They have the 4, but I would see. Oh. So what they are doing, I would do this way. Please excuse exponents. Number 3 is what? Multiply, divide, left to right. I don't want to write all that either. I'll be honest. But if I don't, I'm going to mess it up. And last is add, subtract. Left to right. Let me give you a quick example. I had to think for a moment. There's that one. Okay, there's a couple little examples. This is where you have the multiplication division mixed up. This is the toughest one, but I go left to right. So I have to do these two first. What's 2 times 8? 16. Then divided by 4. And by the way, this is exactly how I would show my work. And that would be 4. Some people might want to take the 8 divided by 4 first, but that would be wrong, even though it works out. What about this one? A lot of people want to go 2 times 4 because they don't want to do that division. But the division comes before the multiplication. So I always go left to right. What's 12 divided by 2? Half of 12 bucks. Half a dozen eggs. 6. Times 4 is what? 6 times 4 is 24. Okay. That's one that gets kind of tricky. So let's do 1 and 2 together, and then I'm going to let you work on these. And there's some hard ones on here. And then tomorrow we'll probably work in the book, but I'll make a worksheet for you. I took the picture. I tried to get it to work on my printer, my wireless printer, but that wouldn't work last night. So I finally gave up. So number 1, okay, you should try it before I do it, because I have to write it down. Okay, Michael? So you're going to try that. What do I do first? You should have the order of operations written down as well. The exponents. So I should do the 2 cubed first, which is what? Now watch how I'm going to do this problem. You guys do a bunch of chicken scratch. No, it's 8 times, and you recopy everything that's left. You just don't write 8 down and then do something else someplace else, because I can't follow your work. Guess what? You can't follow your work. So you want work to be organized so somebody else can understand it. Yes, this is not something that's rocket science, but if you are doing rocket science, you got to make sure somebody can understand it. So Gabe, what do I do next? What's next here to do? Yeah. Nope, 8 times 3. Well, I could do the 1 too, but anyway, so it's 24 times 1 minus 3. Josh, what do I do next? Still do the multiplication. What is 24 times 1? 24. Take away 3. And what's the final answer? 21. I'm hoping you're finding these easy. I don't want them to be hard. You just have to follow the rules. And yes, I'll be collecting this, so if you don't have the top part, I can slide it. Let's try number 2. Ready? I have to write it down, though, so you try it. That is not 9. This is not an easy one. It's not an easy one. Well, let's do the first things. I do all the exponents. Now, here's the trick. If you don't want to do one thing per line, you don't have to. You can do a couple things. But we have to do all the exponents. If I can do all that in one line, that's great. What is 3 cubed? Anybody know what that is? 27. Good. Plus. Let's do that next exponent, because the pluses are the last thing I'm going to do. So I got to clear everything else out. So we can go ahead and do this. What's 3 squared? 9. Divided by 3 times 5. That's what I should see written down. Some of you, maybe you can do the whole thing in your head. I have a hard time with it. So it's 27 plus, because I can't do that. That's the last thing to do, but you need to keep it there. Otherwise, we're going to get confused. Do I get to multiply the 5 and 3 first, or do I divide first? You divide. So that's what? 3 times 5. Okay? 27 plus, last thing I'm going to do is add. Let's go ahead and multiply. What's 3 times 5? 15. And now, either you're probably going to use a calculator, or you might have to write it out like I do. Because what I do is I forget to carry. Or sometimes I carry too much. I went to the bank and I gave myself an extra $100. But they caught it. Anyway, 7 and 5 is 12. Carry the 1. I carried when I wasn't supposed to. 3 and 1 is 4, so that's 42. And then it's kind of nice to circle your answer because it kind of stands out. Now, you see how it's all written down, Josh? That's what I want to see on your paper. I want to see the steps. Minimally, I should see the 27, and I could do this. 9 divided by 3 is 3 times 5 is 15. I need to see at least that. But if I don't get that and it's wrong, or, whatever. So I'm going to let you guys work. I'll write up an answer key. And ask for help, Michael. Okay, let's try this. There it is.